Hi student, welcome to my YouTube channel. My name is Professor Prakash Vasankar, author Engineering Mathematics first, second and third for B first year and second year for all branches. Mathematics part first and second for class 12. Today we solve some problem on unit differentiation from mathematics part second for class 12. And here problem number next problem, that is problem number 11, and problem number 11 is problem number 11. Again, in this problem I find dy by dx if y equals to some function, that is the composite function is given. So here we find dy by dx, find dy by dx if y is equals to tan of cos of sin x, cos of sin x. This is the given function, that is y is equals to tan of cos of sin x, and differentiate these functions with respect to x and find out ddx of y, that is dy by dx. So first we write here the given function. This is the given function. We write this given function here is the given function. Then here differentiate both sides with respect to x. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Then ddx of y in LHS, here y is present, and differentiate y with respect to x. So we get ddx of y, that is a dy by dx. So we write here dy by dx, which is equals to ddx of RHS function, ddx of RHS function, and here RHS function is tan of cos of sin x. So we write here tan of cos of sin x. Therefore, here dy by dx, that is LHS as it is, which is equals to. We find ddx of tan of cos of sin x, and we know that the simple derivative formula ddx of tan fx sec square fx into f dash of x, that is ddx of fx, and here fx replaced by this function, fx replaced by this function, that is cos of sin x. Again we repeat this. Here we find ddx of tan of cos of sin x. So we use here the simple derivative formula. We know that ddx of tan fx sec square fx into f dash of x, that is ddx of fx. And here fx replaced by cos of sin x. Therefore, the derivative of this function, that is tan of cos of sin x, is sec square cos of sin x into ddx of cos of sin x. So right here sec square, this cos of sin x. So right here cos of sin x into ddx of this red color function, that is cos of sin x. So we write here ddx of cos of sin x, ddx of cos of sin x. That is here we use indirectly chain rule. And for using chain rule, we use here the simple derivative formula ddx of tan fx, here sec square fx into f dash of x. and fx replaced by this red color function, that is cos of sin x. Therefore, here derivative is ddx of tan of cos of sin x sec square cos of sin x into ddx of red color function, that is cos of sin x. Therefore, here dy by dx, which is equals to sec square cos of sin x, up to this as it is. So right here dy by dx sec square cos of sin x as it is into, we find here ddx of cos of sin x. We find here ddx of cos of sin x. And for finding out the derivative of this function, we use here the simple derivative formula. We use here simple derivative formula, ddx of cos fx minus sin fx into f dash of x. Similarly, here ddx of cos of sin x minus sin of sin x into ddx of green color function, that is ddx of sin x. So we write here minus positive negative negative sin of sin x, sin of sin x, where this sin x ddx of cos of sin x minus sin of sin x, so here minus sin of sin x into ddx of green color function, that is ddx of sin x. So right here ddx of sin x. Therefore dy by dx, that is LHS as it is, which is equals to up to this, that is minus sec square cos of sin x into sin of sin x as it is. So right here up to this as it is. So we write this here into ddx of sin x. We find here ddx of sin x, and ddx of sin x is here. We know that this is the standard formula. ddx of sin x is cos x. So right here cos x, and this is the required derivative of the function, that is y is equals to tan of cos of sin x. We find the derivative of these functions by using indirectly the chain rule, and derivative of this function is here dy by dx is equals to minus sec square cos of sin x into sin of sin x into cos x. So in this way we solve problem number 11 from exercise 1.1 unit differentiation from mathematics part second. So dear student, if you like my video, please subscribe my channel and press on bell icon. Please subscribe my YouTube channel and press on bell icon. Next, that is problem number 12. Next we solve problem number 12. Again in this problem, we find dy by dx if the function is given. Right here, the problem find dy by dx if here y which is equals to, and again when here the composite function is given sec of tan of x to the power 4 plus 4, sec of, in bracket here, tan of x to the power 4, x to the power 4 plus 4. This function is given, and we find here the derivative of the function, that is y is equals to sec of tan of x to the power 4 plus 4. So first we write the given function. This is the given functions. We write this function in solution first in the given function. Y is equals to sec of tan of x to the power 4 plus 4. Then differentiate these functions with respect to x and find out this dy by dx. So differentiate both sides with respect to x. Then here ddx of y, dy by dx. So right here dy by dx is equals to ddx of this sec of tan of x to the power 4 plus 4. We write right hand side here, that is ddx of RHS, ddx of sec of tan of x to the power 4 plus 4. Therefore, dy by dx, which is equals to, that is LHS as it is. ddx of sec of tan of x to the power 4 plus 4. And here we use the formula. We know that ddx of sec fx into tan fx into f dash of x. And here fx replaced by this function. Fx replaced by a red color function, that is tan x to the power 4 plus 4, which is equals to fx. ने जो फॉर्मूला है आपका ddx of sec fx, तो sec ddx of sec fx into tan fx into f dash of x. In this formula, fx replaced by red color function tan x to the power 4 plus 4. So I write here, first I write here the ddx of sec of tan x to the power 4 plus 4. So sec x to the power 4, sec x to the power 4, sec x, that is sec fx into tan fx. So right here tan fx, but fx is equals to this red color function, red colored function, sec fx into tan fx. So sec tan x to the power 4 plus 4 into tan x to the power 4 plus 4 into f dash of x, that is into ddx of tan of x to the power 4 plus 4. So right here into ddx of this tan, that is the red color function, tan x to the power 4, tan x to the power 4 plus 4, tan x to the power 4 plus 4. Therefore, dy by dx is equals to, up to this step, as it is. So we write this as it is. Next, we find here the ddx of tan x to the power 4 plus 4. Next, we find ddx of tan x to the power 4 plus 4. So here we use the simple derivative formula. That is ddx of tan fx, sec square fx into f dash of x. But here fx replaced by x to the power 4 plus 4. Fx replaced by x to the power 4 plus 4. That is the green color function. Green color functions. Means here sec square, here green color function into ddx of again green color functions. So we write here into ddx of tan x to the power 4 plus 4. We find here ddx of tan x to the power 4 plus 4. And here we use the formula ddx of tan fx, sec square fx into f dash of x. And fx is equals to here, fx replaced by this green color function, that is x to the power 4 plus 4. So by right here, sec square, this function, that is the green color function, x to the power 4 plus 4 into ddx of again here the green color function, that is x to the power 4 plus 4. Again we repeat here the formula, we use here formula ddx of tan fx, sec square fx into f dash of x. Similarly here sec square x to the power 4 plus 4 into ddx of x to the power 4 plus 4. Therefore here again here up to this step as it is, up to this step as it is. So we write this here up to this step as it is. Next we find here ddx of x to the power 4 plus 4. And we use here the addition rule. ddx of u plus v du by dx plus dv by dx. And u replaced by x to the power 4, v replaced by 4. So here ddx of x to the power 4. We find here ddx of x to the power 4 by using the formula ddx of x to the power n, x to the power n minus 1. Similarly here ddx of x to the power 4, 4, x to the power 4 minus 1, that is 3, plus ddx of 4. And we know that the standard formula ddx of k equals to 0, where k is constant. Similarly, ddx of 4, 4 is constant, therefore derivative is 0. Therefore, here the required derivative of the given function is here we write dy by dx, which is equals to this first we write this 4x cube, this 4x cube as it is, into up to this step into these functions. And this is the required derivative of the given function, and that function is y is equals to sec of tan x to the power 4 plus 4. We find here derivative of these functions. And this is in exercise 1.1. This problem is 12 number problem number 12. So in this way, we solve problem number 12 from unit differentiation exercise 1.1. So again, I request you, if you like my video, please subscribe my channel and press on bell icon. So this is the process for finding out the derivative of the given composite function with the help of, that is here we use indirectly the chain rule. Okay.